Alright, this is going to be the video on lesson 2.2. Alright, so the do not question says, what is the difference between constant velocity and acceleration? Constant velocity means you're traveling at a constant pace, right? Your speed is constant. You're not changing your speed. You're not increasing. You're not getting faster or slower. You have a constant velocity, right? Your speed is constant. Whereas the acceleration, essentially you're saying that, well, my speed is increasing, or rather not increasing, or my speed is changing, right? Acceleration is essentially changing speed over time. That's what acceleration is, right? Your speed is changing. So here we get to this next slide. Now, in the past, I said that, the negative sign indicates really just west or south, right? In the past, I've said that. But in physics, that's not really the case, or rather, that's not the entire situation, that's the entire story. Your negative sign in physics, right? So your negative sign in physics, it actually indicates the opposite direction of the positive, which is, as it says on the slide right here, right? It indicates the opposite direction of your positive. What does that mean, right? Doesn't that just mean the same thing? Doesn't it just mean west is negative and south is negative as well? But let's just take a look at these examples. So let's say north is positive, right? So north is positive. Well, that must mean my south is negative. And if east is positive, then my west will be negative. Right? So if east is positive, then west will be negative. And if we treat south as positive, then my north will be negative as well. So it really depends on which direction we're treating as positive. Right? We can say that my north is positive, or I can say that my south is positive. But in both cases, our negative sign really just means the opposite direction. Right? It's always the opposite direction of your positive, right? So it depends on which one you're classifying as positive or negative. Speeding up, so same direction. So here's something that is something I would explain in AP physics, right? But it wouldn't be something I would explain in Regents physics. This is really just coming down to memory. So if you're speeding up, right, if you're getting faster, the signs of your velocity, there must be signs for both velocity and acceleration. And if you're speeding up, you can either have a positive velocity or a positive acceleration, or a negative velocity and a negative acceleration. Right. So the rule here, as you can see to the image on your right, if you're speeding up, you must have the same signs for both acceleration and velocity. Right. So the signs must be the same. Now, on the other hand, if you're slowing down, well, you must have the opposite signs, right? So your velocity must either be, your velocity and acceleration must have opposite signs. So, for example, if velocity is positive, then my acceleration must be negative. And vice versa, if my velocity is negative, that must mean my acceleration is positive. Right? So if you're slowing down, you have opposite signs, and if you're speeding up, you have the same signs, same direction. Right? And it's really just something you need to remember. It's not something I can I would like to go deeper into, because that's just a waste of class time. Now this unit, as it's aptly named, it's called kinematics. Now, what is kinematics, right? In unit 1, we talked about things that cause motion, right? If we apply a force, we change an object's motion. But kinematics is really just a study of motion without really studying what causes it. Right? So position, velocity, and acceleration. And you guys can watch that on your own. So now we come to the kinematic equation, the kinematic formulas. And there are 5 symbols in this unit that we will use, right? There are 5 symbols in this unit that we're going to use. The first symbol is called acceleration. And acceleration is measured in meters per second squared. And in written format, you might see it like this, written like this, right? Meters per second squared. The second symbol you might see is displacement, and that's m, right? That's m, right? And that's measured in meters, right? So meters, if you ever see the unit meters, well, that's going to be your distance or displacement. And time is measured in seconds, right? So time is seconds. It's something you guys should know. And velocity is measured in meters per second. Now, this shouldn't be a too difficult concept for you to kind of translate, right? Because in American units, we measure speed in miles per hour, right? We do miles per hour. But in metric system, we either do meters per second or kilometers per hour. And this really isn't too far of a stretch to realize, well, this is talking about my speed, right? If I say something that has 5 meters per second, it's traveling at a speed of 5 meters per second, well, you would say that that's your velocity. That's how fast you're going. And just because you went from American units to metric doesn't mean anything's changed. Now, the accelerator, and same thing for distance or displacement, same thing for d. Because you measure length in American units in either inches, feet, yards, which is essentially one word, right? It's one word, one entire word. So if you see something like 5 meters, well, you're still measuring distance, right? Just because you switch to meters now, so just because you switch to the metric system doesn't mean you're measuring something entirely different. You're still measuring distance. You're still measuring displacement. So things like that. And the formulas you see on the right hand side are something you can go on your reference table. It's actually on the 6th page. It's on the 6th page. Right, so you see your kinematic formulas over here on the top. So let's talk about how we use those kinematic formulas, right? So let's get to our first practice problem. So our kinematics, so cars traveling west, right? So cars traveling west, so the car is going west. And a straight line on a highway decreases its speed. I'm decreasing speed from 30 meters per second to 23 meters per second in 2 seconds. Now, something that there's this first step here, right? And so step one is to figure out, well, figure out 3 pieces of information that you know. The problem is telling you that you're decreasing your speed from 30 meters per second to 23 meters per second. Now we're gonna identify our information we know from our knowns, from our 5 variables here, right? Either acceleration, displacement, time, initial velocity, and final velocity. So we're gonna classify information as pieces of those. So we see this unit here, right? So we're going from a speed of 30 meters per second to 23, and we see this unit. We see this unit called meters per second. Now this is a unit for something, right? This is a unit for velocity. Well, is it my initial velocity or is it my final velocity, right? Well, let's look at the context of the problem, right? It says on a highway decreases its speed from this number to this number. So we can basically infer from the context of the problem, well, my initial velocity is 30 meters per second, right? And this is because it's my initial velocity, this is my starting speed. And my final velocity is 23 meters per second. Right? Because again, we see this unit here, 23 meters per second. That's a velocity value. But here's the thing. This object is going west, right? This car is going west. Which means that, well, let's just say that my negative direction is west. So I'm going to say that, well, my initial velocity is actually negative 30 meters per second, and my final velocity is negative 23 meters per second. And so now we have 2 pieces of information now. And our third piece of information, well, that's 2 seconds. And that's 2 seconds. And so there's 2 seconds there. And we know it's time because it's measured in seconds. And then the car's average acceleration during this time interval is what? And so what is A? Now we're gonna look at our 3 formulas, or rather, because we only really mainly use 3 formulas. I know there are 4 formulas on the other slide, but really we only use the 3 main ones. All right, so let's look at this. V equals VI squared plus 2AD. So VF. So let's look at, well, how do I figure out which formula I want to use? Let's look at the 4 things we know, right? So the formula we're going to use are essentially contains all the 4 variables that we either want to solve for or that we know. So let's take a look at the bottom formula down here. So do we have our final velocity? Yes, we have our final velocity. All right, do we have our initial velocity? Yes, we have our initial velocity. Do we have our acceleration? Well, we're solving for our acceleration. But do we have D? Do we have D? Well, no, not really. We don't really have D, right? So there's no possible way we can use this formula. Right, so let's just get rid of that one. Let's go to the second one. I'll write this one here. Do we have D? Nah, we don't have D. Sure, we might have everything else, but we do not have D, which means you cannot use this formula. Cannot use this formula. All right, let's look at VF. Let's look at this one, right? Do we have final velocity? Yeah. Do we have initial velocity? Yeah. Do we have A? Yeah, we want to solve for A. And do we have time? Yes, and that is true. We definitely have time. So 23 meters per second. So now we just need to plug things in, right? So VF is negative 23, VI is negative 30, A is A, and then T is 2. So you have this. So plus 30 plus 30, negative 7. Oh, so before that. So the reason why I'm doing plus 30, right, is because I want to get A by itself. And to get A by itself, I need to remove things that are the furthest away from A. Right, so 2 is the closest. The 2 is the closest. And now negative 30 is the next thing that's furthest away. Right, so let's get rid of the negative 30 first. Well, how to get rid of a negative 30? It's being added to 2A, so we need to do the opposite of whatever's here. Since this is negative 30, we're going to add 30 to both sides. Right, so now we have negative 7 is equal to 2A. And I'm going to divide I'm going to divide by 2 here because the operation here is multiplication. And if I want to get A by itself, we'll have to do the inverse of multiplication. I have to divide by 2 on both sides. So negative 7 divided by 2 gives me negative 3.5 meters per second squared. All right. And that's my answer. Now, negative, or because it's negative, right? And negative is the opposite direction. Oh, I'm sorry. This is not negative. This is actually positive 7. This is positive 7. I'm sorry, guys. I'm sorry. This is positive 7. It's positive 7. And so that's going to be a positive 3.5 meters per second squared. Right? And because it's positive, well, we're going to go eastward here. All right? Okay. All right. That's that. Let's move on to the next question. The question says, what is your final speed of the object that starts from rest? So the first thing you see is, well, what is the final speed? That's essentially what you're solving for, right? So you're solving for your final speed, final velocity of an object that starts from rest. Now, this is very important, right? This is a very important keyword. You're going to see that a lot. Starting from rest. That means you're not moving, right? To be at rest means you're not moving, which means you can basically say that our initial velocity here is 0. It accelerates uniformly at 4 meters per second squared, right? So you're accelerating at 4 meters per second squared. And there are two ways you can tell that this is your acceleration. You can tell because by the context, right? They're saying you accelerate at this. And the second way, which is the primary way, is, well, you can tell from the units, right? The units say that this is meters per second squared, right? The meters per second squared. So you know that's a unit for acceleration. And even if you weren't able to read the problem, you can definitely read the unit over a distance of 8 meters. So you have a distance of 8 meters here, so you can tell based on the context. There's also the unit, it's meters. So now we have to figure out a formula to use. And if you take a look at your 3 formulas, you'll realize that the only formula you can use is this one, because this formula is the only one that has everything we know and everything we want to solve for. I'm sorry, this is not it. This is this one. Everything we know and everything we want to solve for. Right? Because it has final velocity, as initial velocity as A, and as D. And so now we just solve, right? So VI is 0 to 4D. Right? So 8 times 8, 64. So right? So 2 times 4 times 8 gives you 64. And now you're left with V squared. Well, how do I get rid of the square? Well, I have to square root of both sides, right? So this is going to give you 8 meters per second. All right. So let's do the final practice, or rather, third practice. So in a race, a runner traveled 12 meters, right? So 12 meters, you see the meters, so you know that's distance, right? That's D, that's displacement. So it's 12 meters here. Now in 4 seconds, right? So that's my time, 4 seconds. You can tell because, well, seconds measures time. As she accelerated from rest, right? So if you're coming from rest, that means you start at a velocity of 0. So this is my initial velocity. And the question then wants you to find out, well, what is the acceleration? Right, what is your acceleration here? So the only formula we can use is this one, because this one has all the variables we need, or rather have, right? We have D, VI, T, and we're looking for A, and we have T. So again, at this point, you're essentially just plugging things in. 0 times anything, by the way, is 0. So I'm just going to leave it as 0. 0 times anything is 0. So A, 4 squared. So 1/2 times A times 16, right? 4 squared is 16. You do your exponents first. And then you can do 1/2 times A times 16. So you do 1/2 times 16 gives you 8. So that's 1.5 meters per second squared is acceleration. And that's it. All right, so let's do 3D now. So it says here, if a car accelerates uniformly from rest, right? So you know that you're starting from rest, which means that your initial velocity here is 0 to 15 meters per second, right? So you're going from one speed to another, right? So you're going from rest to another speed. So you know this is a speed because it says units, right? So it says meters per second. You know that's a velocity unit. So you can essentially say that my final velocity here is 15 meters per second. And we keep reading this problem and say it's over a distance of 100 meters. So you know this is your distance. Right? And you also know by context and also because you see the unit. And then the magnitude of the car's acceleration is what? Right, so what is my acceleration? And the only formula we can use here is Vf squared is equal to Vi squared plus 2AD. Right? We have Vf, we have Vi, we have A, and we have D. Well, we're solving for A. Right? So it has all four of these variables. Right? So 15 squared is equal to 0 plus 2, A 100, 225. 2 times 100 gives you 200. And again, we want to get rid of this 200 by dividing, because again, this is a multiplication here. So 200, 1.125 meters per second squared. It gives you A. Okay? And that's that. All right. Good enough. Good.